All right, we are going to do parametric equations, notes on chapter 10, section 6. Parametric equations are used when it is necessary not only to know where you are in length and height, but also to know where you are in time. So we take an equation that is in the xy plane and we introduce a third parameter called t, usually. So our definition, if f and g are continuous on t, the set of ordered pairs f of t, g of t makes a plane curve c. The equations x equals f of t and y equals g of t are a set of parametric equations for the curve C with t as the parameter, which sounds awfully scary, but it's not. It's just taking one equation and breaking it into two. So let's look at sketching it. Well, sketching it is the way we have always sketched to start with, and that is just to make a table, and we get our xy values from whatever the equation is for t. So we plot the points, and then we also have to add an extra thing, which is the orientation of the curve, which is the direction that we graphed it in. So let's try one. It might sound difficult, but it's not that bad. All right, we're going to start with a lovely little curve. All right, x equals t minus 3. And y equals t squared plus 1. So we're going to create a table of values, only this time it's not just an xy table. It's a t x y table. Our t values have been noted to be only from -1 to 3. So let's do -1, 0, 1, 2, 3. And then we just plug them in to get our x's, which you guys know how to do. So you can pause there and do it. And I'll go ahead and do this. -4, -3, -2, -1, 0, and 2, 1, 2, 5, and 10. All right. Then we head over to the graph and we graph the points x, y. Okay, so I pause it here and you can do that. And now I'll show you what it should look like. -4, 2, -3, 1, -2, 2, -1, 5, and 0, 10. And then you just connect them and put your orientation. Your orientation are just little arrows showing, okay, I started here and I went this way. All right, so that's that. You can also use your graphing calculator. Set it to parametric mode, that is mode, and then the PAR one. And then graph those little things, x equals t squared and y equals t cubed. And have a look at it. You can pause here. And you should get something that looks like a birdie. All right, eliminating the parameter, taking it back to rectangular equations. The easiest thing to do is to solve it for t, solve one equation for t and substitute it into the other equation. My dog Watson enjoys barking at the neighbors. Okay, so we substitute and then we simplify. So eliminate the parameter in one of the equations. So, well, let's solve this first one. What will t equal? And I hope you have 1 minus x. And then plug it into the second equation for t. And you do that, and you should get y equals 1 minus x squared plus 1 minus x minus 2, which will be 1 minus 2x plus x squared plus 1 minus x minus 2. So we have 2 minus 2, and we have x squared minus 3x is the final equation. Lovely enough. All right. Occasionally, you'll have to deal with the trig functions, and those will be identities that you'll be using to eliminate those. So if we look at this set of parametric equations, x equals 3 cosine of theta and y equals 4 sine of theta, you'll see that we don't have anything fabulous there that we could use. We can't really solve for theta and plug it into the other one. So what we'll do is we will use the identities. So you will see, let's start by squaring both. X squared equals 3 squared cosine squared theta, and y squared equals 4 squared sine squared theta. So cosine squared is x squared over 9, and sine squared is y squared over 16. And then we should remember an identity involving cosine squared and sine squared, which I think their sum is 1. So we have cosine squared plus sine squared equals 1. Or x squared over 9 plus y squared over 16 equals 1, which hopefully you remember is an ellipse. All right, and our last one is making up a set of equations for the parametrics to go from rectangular to parametric. So the only one I'm not allowing is x equals t. Please don't do that. I don't think that would be very good. So we want x minus 5 to equal t. So we can substitute it in easily. And then that makes t, or x, equal t plus 5. And then y equals t squared. All right, so you just take one part of the equation and you let that equal t, and then your pair of equations are x equals t plus 5 and y equals t squared. So there are the parametrics. Enjoy your work.